Example 4C. If the person wants to make withdrawals of $2,000 per month for the last 15 years, how much must be deposited monthly for the first 30 years? Okay, this problem is actually part A, but worked backwards. So it's going to be a little bit challenging. Okay, so remember what went on in part A. Let's talk about that real quick. If you go back up to part A, okay, the person spent 30 years saving for retirement. Okay, so they contributed $100 a month for 30 years. Okay, the money grew through those regular deposits. Okay, and through the interest, and that helped the person build a nest egg of $133,137. Okay, that's how much they had at the time of retirement. And then once they retired, they started withdrawing money from this nest egg. And we calculated that they were able to withdraw $1,229.66 every month for 15 years. Okay, so we had these monthly withdrawals coming out of the nest egg, but also whatever money was still in the account was able to still earn interest. Okay, so now in part C, okay, we're kind of doing the planning backwards. Okay, from part A. Now we want very specific withdrawals out of the account. We want to be able to receive withdrawals or monthly checks of $2,000 once retired. Okay, so we want to bump up, basically, we're bumping up the amount that's being received during the 15-year period in retirement. Okay, so we're going to go from a $1,229.66 paycheck to a $2,000 paycheck. Okay, so we're working backwards. If that's the amount we want to receive every month during retirement, we have to figure out how much do we have to save every month during our working years in order to accomplish that goal. Okay, so think about how part A played out. Okay, the first part of the problem, you spent savings, so you used the future value of an annuity formula. Okay, and then once you retired, you had to figure out what your monthly withdrawals would be, and you used the present value of an annuity formula to figure that out. So now we're going to go backwards. Okay, we're going to handle kind of the withdrawal phase first and use the present value of an annuity formula. Okay, and then once we work with that, then we will go back and go to the savings phase and use the future value of an annuity formula. Okay, so again, it's a little challenging because you're basically doing part A, but backwards. Okay, all right, so let's start this problem. Okay, so we know that the person wants to make withdrawals of $2,000 per month for the last 15 years, which is the retirement phase there. Okay, so we're going to go ahead and start here this time with the withdrawal phase. Okay, so we know during the withdrawal phase, that's when an annuity is being paid out. So we're going to use the present value of an annuity formula here. Okay, all right, so this is going to help us figure out, well, you'll see in just a second, make sure your exponent here is negative. I almost forgot the negative sign. Okay, all right, so we're using this formula. Okay, all right, so let's figure out what we know, what we're looking for. Okay, all right, obvious stuff first. Okay, the interest rate hasn't changed because we're still working within the same example 4 here. Okay, the interest rate that was stated was 7.44%. Okay, so we're keeping that interest rate. And then again, everything here is going to be done monthly. Okay, the withdrawals will be made monthly. That corresponds to how often the interest is being compounded. Okay, time here, this withdrawal phase is again happening during retirement during that 15-year period. Okay, so here we need to figure out if we know P or PV. One we know, one we don't know. Okay, P is the amount of each payment to the recipient. Okay, so during the retirement years, okay, the person is going to receive a paycheck for $2,000 every single month for the 15 years. Okay, so that's the amount of each payment to the recipient. That's your p-value. So we're solving here for the PV value, okay? So let's go ahead and plug all of that in to our formula, and then we'll go to the calculator. All right, so this time I won't forget my negative exponent. All right, so this is how you set this up, okay? And again, this is just the first part of the problem, okay? We're dealing with withdrawal right now, and then we'll have to go back to the savings phase, okay? All right, so let's go to our calculator and enter this in. Okay, so let's start in the numerator here. Okay, so we are going to have start in the top. So we're going to have 1 minus, open parentheses, 1 plus 0.0744 divided by 12, close parentheses. Raise this to the negative 12 times 15. Okay, this will give us the numerator. Okay. Then we need to divide by the entire denominator, the R over M. Okay, so hit the division key, open parentheses. You need those parentheses there. Go ahead and put in your R over M. Okay, this is the quantity that is in brackets. Okay, and then we need to multiply everything by the number that is on the outside. Okay, and so that's going to be times 2,000. Okay, so this is the number that we get for the present value. Okay, so let's go ahead and jot that down, round it, and then talk about what it means and then how we go from there. Okay, so back to our notes here. Okay, PV, okay, came out of the calculator as this number. Okay, this is going to be a dollars and cents amount, so let's go ahead and round it. Here we've got 53 cents. The number after is a 7, so we're going to have to bump up here. Okay, so the present value is equal to $216,542.54. Okay, again, this is not the final answer. Okay, would this even make sense as a final answer? No. Okay, because the question is, how much does the person have to deposit every single month for the first 30 years so that they may, during retirement, take out $2,000 a month from their account? Okay, the person more than likely cannot afford to deposit $216,542.54 every month into their retirement account. Okay, if they could, they probably would already be retired. Okay, anyway, what does this mean? Okay, this was calculated from the withdrawal phase. This is the present value of the account. Okay, so what this means, we calculated this number in mind with what information in mind? That the person's going to want to be able to take out $2,000 every month during the last 15 years. Okay, so what this is telling us, in order to be able to take out $2,000 every month for 15 years, this is the amount of money that needs to be in the retirement account at the time of retirement. Okay? This is how much the person has to have in their account at the time of retirement in order to receive monthly amounts of $2,000 for 15 years. Okay? All right. So we're done with the withdrawal phase. Now we can move on backwards to the savings phase. Okay? So I'm out of room on here. Okay, so I'm going to go to the next page and continue this problem. Okay? We're going to enter the savings phase now. Okay? So I'll go down here. Let's say this is example 4C that we're continuing. Okay? So now we're going back to the savings phase. Okay? All right. So if you read the question again, we're trying to figure out the end goal here is to figure out how much the person has to deposit monthly for the first 30 years. Okay, and that's the savings phase. Okay, so since the person would be making regular contributions into a savings account, okay, some deposit, we don't know how much, but they're going to make it every month for 30 years. Okay, so like I said, during the savings phase, they would be saving money through regular deposits, and there's no withdrawals at this point in time. okay? Because the withdrawal phase, the withdrawals don't happen during the savings phase. They happen during the withdrawal phase, okay? So since the person is saving money through regular deposits with no withdrawals, okay, that takes us to the future value of an annuity formula, okay? So we need to use this formula, okay? All right, so we need to figure out what we're looking for, what we know, okay? All right, so the interest rate is still the same. It does not change throughout this problem, okay? The person is going to make monthly contributions into the savings account, okay? That coincides with how often the interest is compounded. Everything is done monthly, so M is still 12 here, okay? The time is different, okay? We're back in the savings phase. The person saves money for 30 years, okay? And then that brings us to our P and our A. One we know, one we don't, okay? So what are we solving for here? Okay, we are solving for how much has to be deposited every single month. Okay, so we are looking for the p-value. Okay, what needs to be the amount of each regular deposit? Okay, so that means we should know our account balance. Okay, again, we're working backwards. Okay, what did we just calculate a few minutes ago? We calculated this number. Okay, this number, this needs to be the balance of the retirement account at the point of retirement. Okay, so in the savings phase, this is going to be your A. Okay, this needs to be the account balance at the time of retirement. Okay, so let's go ahead and write that number in. Okay, that's going to be your A value. Okay, so A is going to be $216,542.54. Okay, so that's going to allow us, by setting it up this way, okay, this is going to allow us to calculate what the monthly contribution to our savings account needs to be so that the money grows through these regular deposits and through the interest, and that will allow us to get an account balance of $216,542.54 going into retirement. And then if that's our account balance going into retirement, okay, then that is going to allow us, okay, according to this withdrawal phase, that's going to allow us to take out $2,000 a month in the 15 years of retirement. Okay. All right. So let's go ahead and plug everything in here. Okay. So we're going to get our A value is equal to P times 1 plus the R value divided by 12 raised to the 12 times 30 power minus 1 all over R over M. Okay, so we've worked with this formula many times. We know we need to start inside the brackets and figure out what we're dealing with there. Okay, so what's on the left will remain the same. Okay, and then on the right side, we're going to have P times some number. We need to go figure out what that number is. Okay, all right, so let's enter this in. Okay, I'll go ahead and clear everything out. We're going to have in the numerator 1 plus R over M raised to the M times T. Get out of the exponent, subtract 1. Here's the numerator. Okay, we need to take that and divide by the entire denominator. Make sure that's in parentheses, the R over M. Okay, so this is the number that P is being multiplied by. Okay, we've got to retain all of these digits, so let's go write that down. Okay, so P is multiplied by this number. All right, and then P is multiplied by this. So to undo that, we've got to divide both sides by this number. And then that will be the answer to our question. All right, so on the right side, this will cancel with this. It will leave us with P. Okay, and let's go figure out what P is going to be. Okay, all right, so we're going to have $216,542.54, and then we want to divide by this decimal that we just got out. So I'm going to do second negative sign, okay, and then that will give me the amount. Okay, this is going to be dollars and cents, so we're going to have to round. Okay, so let's jot this down and then we will write down our answer. Okay, so P is going to be this amount. All right. Okay, so if we round this, okay, so this is dollars and cents, you've got 64 cents, okay, and then, oops, the number that comes after is a 6, okay, so we are going to have to round it up, okay, so the amount of money that the person would have to contribute every month is going to be $162.65, okay. Is this a sensible answer? Okay, well, think back to part A. Okay, in part A, the person, by making monthly contributions of $100 every month for 30 years, they were ultimately able to take out $1,229.66 every month for 15 years during retirement. Okay, so if now we're trying to increase the amount that's being taken out during retirement to $2,000 every month, okay, the person would have to contribute more than $100 each month during the first 30 years. Okay. And so this amount that we got, $162.65, it is more than $100. Okay. So, and it seems about right. It seems like this is a reasonable amount to have to contribute every month for the first 30 months. All right. So we are done with present value of an annuity. Okay. And we're going to move on and start talking about amortization.